Hello everyone, welcome to your first panel discussion for the Summit, where we will be discussing ZK security. We'll be diving a little bit into the security challenges, the adoption challenges, and also maybe we'll touch upon the idea of future when ZK security will support the Web3 ecosystem itself. I'm very excited for this panel discussion, but before we get started, a quick introduction from each of the panelists.
Hi, hello everyone. I'm Akhil, the founder of Dojima Network. At Dojima Network, we're building an omni-chain L1, trying to bring together the whole of Web3 space onto one unified layer. So we started out in 2021 and we made a lot of progress. We launched our testnet a year back, and we have a couple of events organized, one on 6th and we have an omni-chain summit on 10th. So yeah, we'll be announcing a few major updates on the 10th summit, so do attend that event.
My name is Reddy Tapu. I try to love technology. I have been associated with Nordic, which is a near to team, as their product and technology head. I have also founded my own company. I work there as the CEO, which is called 1WayX, a platform to get Web2 companies into Web3s with ease. I am, in my cloud, I'm an AWS certified solutions architect. In blockchain, try doing stuff.
Hello, I'm Rahul Saxena, and I have been into the security space in Web3 for quite some time. Usual stuff, smart contract audits, private audits, contest, bug bounties. I've done that. And recently, I've also joined ZK Sync as the protocol engineering team. So, yeah, that's it.
So, my name is Alios. I'm from eSpot, where we provide open source abstraction infrastructure for networks that support this over that. And I need a moderator for this conversation. So, let's get started with the discussion. So, the first question that I have is, so ZK has been a buzzword in almost every technology discussion that's been happening lately, mainly because of its focus on security and privacy. Right? So, what do you think are some of the vulnerabilities in this technology, and also what should we do with that? What are some of its security challenges?
ZK is a great tech for preserving the privacy of the user and preserving the data of the user. But yeah, we ourselves are integrating ZK at major places in our tech as well. But when it comes to the drawbacks or a few of the cons that we need to talk, one major thing is the scalability. So verifying these proofs that are the ZK proofs that are getting generated is very resource intensive. That could be that could introduce a larger overhead for startups that try to come into the space. So working on those lines, increasing the efficiency and reducing the resource intensiveness could make it easier for startups to get into the space. And also there's a steeper learning curve for ZK, and that will make it difficult for all the people to get into the ZK area as well. So so these are a few of the vulnerabilities that I see as of the moment.
Yeah, no, I think the interesting question. Any technology, when it evolves, when it starts, it really has to go through a journey. Now, when you look at ZK, and if you look at ZK has really been in existence for the last 30, 40 years, if you really see. First time when things were, before ZK, we had RSA, we had Diffie-Hellman, these technologies were there which were giving us some confidence. Now, ZK opened a completely new paradigm of solutions. Now, the question here is that what are some of the vulnerabilities? Now, the vulnerabilities arise from the immaturity, or I would say the way things are changing, or the way things are maturing in this space, right? And I think the solutions are coming for many of these problems. If you really look at the way ZK Snark evolved, even ZK Snark had several implementations of ZK Snark came, and many of them had several issues in that. Then suddenly Snark comes, which really removes the requirement of the trusted setup A trusted setup is something which is very important in ZK Smart or ZK technology, where the prover and verifier. So in ZK, if you really describe ZK, is basically we're trying to convince somebody that you know some fact without telling any of the details of the fact. Now that's the zero knowledge proof. And for that to happen, of course, there's a lot of algorithm and mathematics behind it. But then the one thing is that really you start things with something called a private, setup, which is called setup ceremony, where you agree upon some facts, which is called the CRS, which is called Common Reference String, I believe. And once you have this CRS, then you have to throw it away, because if this goes into the hands of any malicious actor or adversary, that could be used. They will just act like the owner of the details of fact there. Now, there are different ways in which these are being solved, which we can talk later. But right now, I think one of the main vulnerabilities, I think, is basically, this one. Then, of course, panelists talked about several other issues with respect to ZK. For example, we talk about, how much time does it take to generate a proof? And even on theoretical grounds, you can talk about it. But then when it comes to the real application, where, for example, in L2, which is a scalable solution, where transactions keep coming, how exactly do you, go, how frequently do you go and gather those transactions, convert them into proof? How much time does it take to build the proof? How big should be the proof, and how much time does it take to verify those proofs? Now, all these are bottlenecks, in my opinion, where a lot of work is still happening. But then I think I am pretty convinced about the progress that, this space has made in the last 2 to 3 years. Thank you.
Yeah, so I think when you talk about ZK security, it's the tip of the iceberg, in the sense that Web3 security itself is Web2 security plus some extra security stuff. And when you talk about ZK security, I think it is Web2 security plus some Web3 security, which is smart contract security, plus ZK security. Okay. So I think, I heard Shashank talk just now, and I haven't heard someone articulate so clearly what's going on in the industry. I'll give an example. Right now, people kind of make fun about auditors and security people on Twitter and say they're all about money and stuff. But the thing you need to realize is that the kind of attacks that are happening in Web3, they are childish. People like Anonymous, Lazarus, Morpheus Lab, you must have heard of them. They literally take down the nuclear power programs of a country. Have you ever thought, what if they create a Web3 division and start going after protocols? Do you think any one of us can take them on? I don't think so. For example, I personally know a GMX, GMX, right? Yeah, GMX developer that works out of Bali and frequently visits a cafe, right? So he is now at a remote Greek island, for example, okay? And it has 2 cafes. How hard it would be to swap out the Wi-Fi that he uses, router that he uses at the cafe, and just see all the traffic that goes through, right? So these are the security attack vectors that people are not even thinking about. And once you cover that, once you cover the Web2 security side of things, the social engineering side of things, the smart contract side of things, then comes ZK security. And ZK security is a beast of its own, because the biggest issues that I have right now in ZK security is that there is something called circuits. Circuits are basically the things that you use to prove a particular thing. So circuits generates proofs, and the things that runs those circuits are called provers, and the things that verify those are called verifiers. So the circuits themselves are under constraint a lot of times. I think a recent bug in ZK Sync was discovered where a circuit was under constraint, so that's it. So by under constraint, I mean, why is it so hard to detect is that if I have to prove to you that x plus y equals to 10, okay, and I write a circuit for that, and I run a test that, if I have to prove to you that x plus y equals to 10, and the correct answer is 5 and 5, and if I write a circuit for that, and I write a test for it, and checking whether 5 and 5 is giving the right answer, it will pass, right? But also, the circuit should fail for 1 and 9, 2 and 8, 3 and 7, but that doesn't happen, because I haven't written the constraints that reject the answer for 1 and 9 and 2 and 8, things like that. So this is a trivially simple example. Imagine we are building a ZK EVM, and we are writing circuits for each of the opcodes, each of the memory, each of the storage inputs, messages, logs, etc. and to determine what should be happening with the circuit. That's one thing, and then determining what should not be happening with the circuit, the constraints. That's a huge part of it, and again, like, that is the implementational issues that I see with ZK, and the fundamental issues that I see with ZK are like, again, a lot, but I don't think we have time to discuss that. So, yeah.
I think there's been a couple of very interesting points that have come out here. I think some of the issues that we've discussed right now are with respect to certain hurdles that we're facing on the adoption and mainly this like scalability. We've discussed a little bit on the security side, especially on the implementation side. What are your thoughts, especially on the usability side? And I'm going to sort of maybe slightly specific. Especially, what are the challenges? After you have mentioned, touched upon this a little earlier, especially for folks who are not that technical, or folks who might not understand cryptography all that well, right? And that's the majority of developers who are transitioning from Web 2 to Web 3, and even folks who've been in Web 3 for a while might not have enough expertise or enough understanding about all of this. So on that front, especially on the usability front, it gets majorly affected because the folks of building itself do not have much of an understanding regarding it. So what are your thoughts on what is state of affairs currently and what would ideally look good?
So right now, if you see the ecosystem, there are fewer companies that are fully into ZK and implementing or developing these solutions. According to my opinion, so what I feel, there'll be two layers of companies. So at the base layer are these deep tech who are fully into ZK and develop solutions that make it easier for companies that come into the space to develop ZK applications on top of them. I've seen the presentation of A-Chains, the first presentation. So they're making things easier to build these ZK layer 2s and all that. There are people that are fully into this ZK and making things easier for all the people that are coming in. So this is what increases the adoption over time. And one more issue that I would like to specifically talk about is the regulatory concerns. So back in 2021, so when a lot of startups were raising for the ZK tech, so I've personally seen these VCs backing out just because of these regulatory concerns and regulatory uncertainty. ZK, when it is used just for preserving data and on the ID side, then it's good to go. But when they are dealing with assets like Zcash or some other applications like that, so in those lines, the regulatory bodies got into it, and there was a breakdown happening at that point of time. But yeah, over time, things will change, and there will be a proper regulatory structure for all of this.
Yeah, no, I agree with Akhil. So he made very interesting points. I was just talking to Anish Mohammed and Mudit just outside. There are different levels of knowledge which is required for you to be able to work in ZK, right? Of course, everybody cannot be a cryptographic expert. Everybody cannot be a mathematics, expert. To really appreciate, our friend talked about circuits, how exactly these circuits, a simple short 256, I think, needs, 20 lakhs or something like that,
Yes.
So those kind of operations we talk about, right? Simple short 256 encryption. So the cryptography maths behind this is very complex. Now the question is that, and any technology for that matter, in my opinion, has to be abstracted to a level where the end user does not need to understand those. If you have to understand how to fly a plane, then only you can fly. Then this becomes very, very prohibitive, right? So this thing has to be abstracted, number one. Number two is that we talked about some of the challenges. How exactly do you build an ecosystem around some platform? For example, it has taken more than 5+ years to build an ecosystem around Ethereum. All the tools, I was talking to another friend of mine just now about, the environment stuff, the infrastructure stuff, for example, the node, management of node, how do you write, how do you test a smart contract, hard hat, foundries, there are so many things which are there. Now, unless you really have this infrastructure built around ZK, it will not be possible for general person to come and start building into this. Now, that is very important. Now, how much time in this take? It's something which really we have to see. But one thing is for sure that GK is solving several problems which are unsolvable. Like my friend said, without GK, you cannot do that, and you cannot scale, you cannot provide the security that this industry is looking for to compete with the mainstream, world, right? So I think that's what I think.
Yeah, so Rahul, I want to sort of contextualize a little further for you. You earlier mentioned about how the implementation of CK itself starts getting more and more complex, especially when you're building out an entire CK. But today you're also seeing how there's like a lot of RAS providers roll up to the service, right? And they focus on this, quite a few providers who are focused on building out and helping you launch entire rollups within minutes, and a lot of them are focused on CK. So I also wanted to sort of touch on this when you.
Can you give me an example of those roll-up as a service thing? Are you Polygon CDK?
Yeah, for example, Polygon. Yeah.
So Polygon CDK, what it does is it already has a base of ZK VM, and it is building on top of that. So the CDK provides you app chains that basically acts like a place where you can execute transactions, and the transactions are bunched together and sent to the Polygon's ZK VM engine. So that is where the proving happens and the verification happens. So it's not that the roll-up service providers are providing proving and verification solutions individually to the app chains. It's just that they have a core of that, and once someone has built that core, they can provide L3 on top of that. Okay, so that's what happens. And regarding your earlier question, I think if you do not really understand mathematics and cryptography, you should not be writing circuits, because that sounds rude, but there is no other way to say it. Your stupidity could cost people millions of dollars of losses. Okay, that's not how you. For example, that, not to disrespect anyone, but that high school kid, transmission levels, right? He's very smart. He's very gas savvy and everything that. That's fine. But as a kid, he wrote Rari lending protocol, right? That got hacked twice. People are not messing around here. You have to understand that when Web 2 hacks happen, the usernames and passwords maybe leak out, but when Web 3 hacks happen, people lose their hard-earned money, okay? So you don't play with that. And why this gets incrementally difficult in ZK security is that someone talked about Zcash, right? Yeah. So Zcash, you might know that it had a hard fork, yes? Why did it have a hard fork? Because they found a bug in their cryptography, they found a bug in the circuits, right? So nowadays, when you find a bug in your smart contracts, you have the concept of proxies and upgradable contracts and UUPS and metamorphic contracts, whatever. But circuits, since they are provers, you cannot change them on the go. It's not like a Web 2 program running somewhere. So you have to write those programs again, deploy them, test them, create verifiers out of them, and then make your chain run again. So there is literally zero scope of mistakes here. And again, the mistakes are very hard to catch. So that's the issue that I see with going ahead with ZK. As was mentioned earlier, that ZK has been around for a lot of time. Yes, the earliest paper came out in the 1980s, 85, I think. So it's not that people don't know about ZK. It's that ZK had to be made succinct so that it can run on blockchain. Okay. So there is a term called succinctness, which makes ZK run on chain. And once you have that, only then you can do it. And what I fear is that the advancement of AI has accelerated the research in all the areas, which means that it has also accelerated the research in quantum computing. Okay? And once quantum computing research accelerates, what should have come after 25 years would be here in 2 years. Okay? So now, not only your cryptographic algorithms have to be succinct, they also have to be quantum resistant. Okay? And with those and the disconnect between cryptographers and people that write circuits is that cryptographers are highly theoretical. They are academicians, they are mathematicians at MIT, Stanford, IIT Roorkee, whatever. And the engineers that are building this, they have to interpret their paper and convert that into code. And that is the ripest place to make mistakes. Okay? So that is also very, very hard to do unless you are working in exact collaboration with the exact person who wrote the cryptography algorithm. Implementing that itself is a headache.
So Ram, do you think this is essentially like an academic problem, like how this theoretical physics and physics experimental physics, right? So is that the kind of parallel you find out here as well with respect to security engineers having to translate to work for cryptography?
Yeah, so I think engineers, by the definition itself, implement what the scientists think of, right? Scientists and mathematicians in this case prove that something is possible. Engineers make that happen in real life, okay? If I talk about rings, fields, abstract algebra, it's quite literally abstract, right? But to implement that on a machine, that's what engineers do. So academicians are right in their own sense that they are pushing the boundaries of what is possible with mathematics, and engineers are right in the sense that they want to implement it and bring it in the real world. What better can happen is that academicians and engineers work in sync with each other so that they can cross-check each other and say that, hey, this is not what I intended, or hey, this is not what should be happening, things like that.
Yeah, I think so. Very interesting point my friend talked about, and change in the trend is happening that academicians are also becoming developers now. So that is the best thing where you also look at the founder of Start for that matter, and many other examples where somebody who has spent 20 years, 15 years in doing a specific research on his case, and that person starts a company and tries to implement things, what really he has done. I think that is something that's changed here. One point that I would like to have a little contrarian view here is basically that everybody should not be required to understand abstract algebra or modulus mathematics, not required. The growth of the system will happen only if you have got tools surrounding it. Now there are cases where you have, you write your solidity. Solidity is household name right now. You write that there are transpilers which kind of compile to a circuit, or something which really is which is compatible to the DG execution there basically. So the point what I was talking about is that you need to have these tools built around it. You should be able to compile it, test it, debug it. Until you have these things in place, I think it cannot really go for the mass adoption.
Makes sense. So I think the general consensus that I'm getting here is that ZK and all the security research that's going to be associated with it is at least in for the foreseeable future, it's going to be a highly specialized field. It is something that is going to require a bit of time and effort. And scalability and usability in all of these problems are going to be things that are solved on the go, as in when the research itself evolves and we get to a place where we're able to make it a lot more easier or a lot more consumable. Simply because of the fact that ZK itself and these securities specifically entails the security of the users, the infrastructure, and also the company that's associated with this. Right? So I think we are almost at time. I think, but I'm going to try to take one question from the audience in case there's anybody who's got it. Otherwise, we're going to wrap up the panels now.
Once you take, as you mentioned, tools are something which can actually help. So one of the generally term for GK is this funnel proofs is one way of actually building something prove formally and then generate the code instead of manually writing the stuff, right? So what is your take on are there any movements?
I think I'm not the specific truth that you're talking about, but in general, my philosophy has been that GK, if you really see, there is technological advancement happening on GK side. The previous snark, there we had, first of all, it was non-interactive, then it became interactive. That's really made it possible for you to make a proof and put it on chain where, so many verifiers can do that in one interaction there. That was one thing. But then the problems came about your, the variables that you are creating in the beginning. Those problems have also been resolved now. But all these are technical progress if you really see. I don't care whether I am a business developer, for example. If I am a technical developer, I don't care about all these nitty-gritties. What I care about is that do I have a simple platform in which I can go and write my business requirement in terms of, in terms of smart contracts, for example. And can I test it properly? Can I, do the stress testing? Can I do, there are, these smart contracts, and I think Solidity Scan is one of the best. I have also got their services for getting some of my smart contracts audited. I think one variable and variable type, if you do mistake, then you are done. So the point is that, do you really have an ability? If you are talking about ZK and you are talking about building so many, so much of complex solutions around it. Now it is the tip of the iceberg, right? Rightly told by my friend. In future, the applications are going to be, I am thinking of applications where Web 2 and Web 3 world is integrated. In Web 3 world, if you go for a loan in DeFi, these are all collateralized loans. You have to put money and then only you can get a loan. Now, how do you go and use your credibility or credentials that you have in your fiat world and bring those identities here, and people should be able to give you a loan based on that. Now, so the whole Pandora box opens here, correct? So this has to be abstracted, and believe me, in few years, that stage will come. Today, nobody talks about running a node on Ethereum. Today, nobody talks about, worrying about the APIs in Ethereum. And if you go and look at 2 years or 3 years back, this was not the case. I was struggling to, if you really have to file your transaction on Ethereum, then you have to maintain your own node. That was the time. But look at all the things that really have happened in the last 3 years. So this will also happen. Or this is a little more complex, so it might take more time. But I think the time will come.
Thank you so much, folks. Thank you so much, Akhil, Ravi, our works for joining us in this discussion.